Solving square root and other radical equations. The first thing we want to do is we want to practice checking whether a given x value is a solution of the equation. So in example 1, given this equation, we want to substitute the value 65 for x and see if this equation is true. So we're going to go ahead and substitute 65 for x, and then we're going to see if this left side simplifies to equal 16. So 65 minus 1 is 64, and this is all raised to the 2/3 power. So we want to convert this into radical notation. Remember, the denominator is going to be the index, and then 64 is the radicand, and then we'll raise this all to the power of 2 to give us 16. The cube root of 64, this is 4, and then when we square 4, we do get that 16 is equal to 16. Now when you take a look at the second example, we're going to do the same thing. Take the value of 6 substituted for x and see if this equation is true. So we have the cube root of 6 plus 2 minus 4 equals 2. 6 plus 2 is equal to 8, minus 4 equal to 2. The cube root of 8 is going to be 2 minus 4 equals 2. 2 minus 4 is negative 2, and that does not equal 2. Though it's very close, they don't actually equal each other, so this is not a solution. Now, you should be used to checking whether a given value is a solution, but this is an extremely important part of today's lesson, because as we're solving these equations, you are going to get more than one answer sometimes for x, but you have to make sure that both are possible solutions. So when we're solving an equation with a radical or rational exponent, your first step is to isolate the radical or rational exponent expression on one side of the equation. So here I'm just using a rational exponent as an example. You want to isolate this, the term that has the exponent raised to it. And then you want to raise both sides to the reciprocal power. So if we have x raised to the m over n, you want to take both sides and raise it to the power of n over m. So on this side and this side. What ends up happening over here is this is going to cancel out, so you're just left with x. And then when you simplify this, you're going to get a number. Then you want to take that value of a, or multiple values of a, and you want to check for the extraneous or the false solution. So that's what we just practiced doing. Take all your values of x, substitute them into the original equation, and see if your equation is actually true. Let's go ahead and work out this first example. So we want to isolate the rational exponent. So we want to add 4 to both sides, so that on the left side we have x raised to the 2/3 power, and on the right side we have 25. To isolate the x, we need to raise both sides to the reciprocal of that exponent. So we're going to take the x to the 2/3 and raise that to the 3/2. And then we're going to take 25 and also raise that to the power of 3/2. Now on the left side, what ends up happening is these exponents are going to cancel out. Once they cancel out, we will be left with x, but we actually need to take the absolute value of x, because we can have more than one possible answer. Then on the right side, we want to convert this into radical notation. So remember, the denominator, that becomes the index. This number comes down as the radicand, and then that's all going to get raised to the power of the numerator. So we have the absolute value of x is equal to, the square root of 25 is 5, and then when we raise that to the 3rd power, we get 125. So now that we have the absolute value of x is equal to 125, remember when we have absolute value equations, we're going to get 2 separate answers. So the first one, we have x is equal to 125, and then the second possible answer is going to be x is equal to negative 125. So In solving this equation, we get two possible answers. But remember what I said in the beginning, that checking your answers are extremely important and necessary in this lesson. So we're going to go back to the original equation and check both of these answers. So first, let's go ahead and substitute in the positive 125 for x. So again, 125 raised to the 2/3, we want to change that into radical notation. So we have a cube root of 125, all raised to the second power minus 4, and we want that to equal 21. The cube root of 125 is 5. 5 squared is 25. And 25 minus 4 is indeed 21. So this one checks out. Now let's check the second one. Negative 125 raised to the 2/3 minus 4 equals 21. So we'll change this again into radical notation. The cube root of negative 125 squared minus 4 equals 21. So the cube root of negative 125 is negative 5. Negative 5 squared is positive 25. And positive 25 minus 4 is positive 21. So both answers are solutions to this equation. So you would give your final answer as x equals positive 125 and x equals negative 125. Now let's go ahead and work out the second example as well. So first we need to isolate the rational exponential expression. So add 5 to both sides. Then on the left side we have x plus 7 raised to the 3/4 power is equal to 8. And then we want to raise both sides to the reciprocal power. So that 3/4, we want to raise this whole side to the 4/3. And same with the 8, we'll raise that to the 4/3. This is going to cancel out, and then we're left with the absolute value of x plus 7 is equal to, and we want to convert this, cube root of 8 all raised to the 4th power. So we have the absolute value of x plus 7, and then the cube root of 8 is going to be 2. 2 to the 4th power is going to give us 16. And so now that we have the absolute value isolated equal to a number, we can separate into our two problems. So we have x plus 7 equal to 16 and x plus 7 equal to negative 16. And we want to solve these for our two values of x. Subtract 7, so we have x is equal to 9, and then subtract 7 on this side, and we have x is equal to negative 23. So these are our two solutions, and then we need to go through and check and make sure that both of them work. So when we substitute in x equals 9, we have 9 plus 7 raised to the 3/4 power minus 5 equal to 3. 9 plus 7 is 16. And then let's convert this into radical notation. So we have the 4th root of 16 all cubed minus 5 equal to 3. The 4th root of 16 is 2. 2 cubed is 8. And 8 minus 5 is 3. So this solution checks out. So x equals 9 is one of our solutions. And let's check the second one. We have negative 23 in place of x, plus 7 raised to the 3/4 power, minus 5 equal to 3. Negative 23 plus 7 is negative 16 raised to the 3/4 minus 5 equal to 3. And then when we change this into radical notation, we have the 4th root of negative 16 cubed minus 5 equal to 3. Now, when you take a look at this, we cannot take the 4th root of a negative number. Remember, whenever you have an even index, we can't take an even index of a negative number. It's going to give us an imaginary solution. So since we don't have a real solution, we can actually stop here, and we know that x equal to negative 23 is not going to be one of our answers. So in this problem, though we got two answers, x equals 9 is our only solution. Now let's work on a radical equation. So just like we've been working in the two examples, even though it looks a little different, we want to isolate the radical expression. So subtract 7 from both sides, and then we're left with the fifth root of 4x equal to 2. And in this case, in order to get rid of that fifth root, we can actually just raise both sides to the exponent of 5. So if we take this side and this side and raise them both to the fifth power, the fifth root and fifth power, those will cancel out. So we're left with 4x. 2 to the fifth is going to give us 32. Now we can solve for x. Divide both sides by 4, and then we have x is equal to 8. So in this case, we actually only end up with one solution, but we still need to check and verify that that is indeed a solution to our equation. So we're going to substitute that back in. Four times 8 is 32. The fifth root of 32 is 2. 2 plus 7 is 9, which equals 9. So x equals 8 is a solution to our equation. So let's go ahead and work out this last example together. So remember, first we want to check to isolate the radical, and in this case it's already isolated. So to remove the square root, we have to square both sides. Now when we square both sides, 2x minus 3 quantity squared, and then on the right side, make sure to put this in parentheses. The left side, the square root and the squared cancel out, so we're left with 2x minus 3. But on the right side, we actually have a binomial squared. So this is x minus 3 times x minus 3. And so we're going to have to FOIL this right side. So we have 2x minus 3 equal to, first we have our x squared, and then we have minus 3x. And here we have minus 3x. Negative 3 times negative 3 is positive 9. So if we simplify the right side, we get x squared. These combine to make negative 6x plus 9. So we run into a situation where now we have a quadratic. We have this x squared and x terms. So in order to solve for x when you have a quadratic, we need one side to be equal to 0 and all the terms on the other side. So let's subtract the 2x from both sides, and let's add 3 to both sides. So I'm going to do this in one step so that this left side cancels out to 0, and then we have x squared minus 8x plus 12. Now in order to solve for x, we're going to need to factor this right side or use the quadratic formula. This is factorable, so let's go ahead and factor. If we find the multiples of 12, it's 12 and 1, 4 and 3, 2 and 6. We want the multiples that are going to add up to 8, so we get x minus 2 and x minus 6. Negative 2 times negative 6 equals positive 12. Negative 2 plus negative 6 equals negative 8. So now we get our two possible answers, 0 equal to x minus 2 and 0 equal to x minus 6. So when we add 2 to both sides, we get 2 equal to x as one of our solutions. And when we add 6 to both sides, we get 6 equal to x as another solution. So we have two possible solutions, but again, we need to make sure that both solutions actually work. So let's go ahead and substitute back in. we have 2 times 2 minus 3 under the radical equal to 2 minus 3. So 2 times 2 is 4 minus 3. And then 4 minus 3 is 1. The square root of 1 is 1, and on the right side, 2 minus 3 is negative 1. So since these are not the same, that means that x equal to positive 2 is not one of our solutions. So let's go ahead and check the other one. Square root of 2 times 6 minus 3 under the radical equal to 6 minus 3. So 2 times 6 is 12. 12 minus 3 is 9. And the square root of 9 is 3 equal to 6 minus 3 is 3. And since 3 does equal 3, that means x equal to 6 is the only solution for this equation. That's it for this set of notes. I'll see you in class for more practice.